but I can hear you.
Yeah, I can hear you okay. You're a little bit low, but there's a little bit of an echo, but it's not too bad.
How's this?
That's fine.
Better
The same
or worse?
kind of background noise. A little better, a little crisper.
Are you getting any feedback from me when we do this, since I'm right next to you?
That's possible.
Yes.
I don't hear a lot of feedback, but a little bit. You guys are going to hear a lot of feedback because of the
delay.
Yeah, because you can hear each other and then you hear the echo.
Yeah.
But
Yeah,
we're not
so I
hearing that.
I did that with Jordan the other day, and that was unfun. I'm gonna move to lab, I guess. Back in like 30 seconds.
You could use the lounge.
That's a good idea. Wait, can you guys still hear me? I can still hear you.
Yeah, we can still hear you.
That's interesting. That means I'm currently using my headphone mic. And I don't think my laptop wanted to open and shut it. I thought they were... whatever.
I was going to say that sometimes when we have two people adjacent on web conferencing at work, one of us will mute the mic, and that gets rid of any echo or feedback loops.
Mm-hmm.
And you can still hear each other because the adjacent person's microphone still picks them up.
You guys can still hear me?
Yeah, we still hear you. And you are still there.
I walked between the elevators and my Wi-Fi cut out for a moment.
Oh, it reconnected you pretty
Giant
quickly.
I didn't fully disconnect. I just lost audio quality. I couldn't hear what you were saying. It was all chunky.
Oh, okay. I was saying that sometimes on web conferences at work, when two people are sitting near each other, using each of their laptops to talk, we'll mute one of the mics, and that gets rid of any feedback or echo, because all the adjacent person is strongly to pick up what the other person is saying.
Yeah. So back to Albert. What's the cost of the myoelectric portion of your device without all of the actual mechanics or anything?
Are you looking for like a hardware specification, or just like what do we do with it?
Mostly hardware, but both, I guess.
We found off-the-shelf myoelectric reader. Used it on his bicep, on the arm that has the birth defect. When he flexes his bicep, the hand opens and closes through the means of a servo. If it's over a certain threshold, then we allow the servo to move.
Yeah. Oh, so you're just doing binary or doing magnitude as well to
Currently,
do,
it's just
more closed?
currently it's just 0 and 1.
Yeah. Okay.
We have a code that lets you do more than one, where you can, as you tighten it, it will do this. But we think for a 6-year-old, it's better to just start with 0 and 1.
Certainly.
Do you have any other movements besides just the finger closure on
Pardon?
that myoelectric?
One more time?
Do you have any other movements besides just the finger closure?
Not at this time. We'd like to have for the elbow, but at 6 years old, we haven't been able to. There's not enough room yet in his arm, in the forearm that we.
Right.
Right.
So have you got a single servo pulling all of your cables then, or multiple for the different?
This one.
Yeah, 6 tiny. I don't know how you would fit more than one servo.
Yeah.
Here, do you have a link to that board that you bought, the Myo one?
We do.
I'm loading the Google Drive app at the moment so that we can, if somebody wants to take notes, they're welcome to.
at that offer.
Right. Usually Lydia or John pick that up pretty quickly, but
Well, it's on air. They can annotate it afterwards.
right. And I might do so myself. I'm just not very good at doing it while we're having the conversation. It seems like writing and listening are contradictory tasks in my head.
Yes. I want to ask you, Albert, and I guess I want to ask everybody the same, or you as well, Nick. I've kind of, after I missed that hangout yesterday, I kind of got motivated to want to start working on my myoelectric arm. And I don't have any myoelectrics. I was just building a rolling chassis. And I was planning on having a swivel at the humerus above the elbow, and then have the elbow hinge, and then a swivel at the wrist, and then have the hand closure. So that would be 4 movements. Is that even possible to do?
How big's the arm?
It's an arm. I can go get it. It's just an arm that I just got a mannequin arm, and I just cast some fiberglass over it, and I basically got the radial portion of the forearm, and then the humerus portion of the upper arm. And I've got quite a bit of SolidWorks done on the mechanics of it. It was originally going to be a CO2-driven device, but I guess my main question is, can you get 4 inputs to make 4 different things happen? Is that even possible?
No,
So for
not reasonably.
No?
Here, go ahead. Well, you can't get 4 separate inputs, but you can do like different modes. If you put a little dip switch on the side of the arm or something like that,
Mm-hmm.
you can imagine switching to a eating mode or a, I don't know what mode, but
I got you. I got you.
because the
You
trouble
might be
is
able
you
to.
can't. On which muscles?
So we found the bicep worked well. We tried this area right here is actually really sensitive to myoelectric. You can do your stomach muscles would be number 3, and the 4th one would be in your toes, and you could like Bluetooth it to the arm. But
Bluetooth
it's a
is
lot
a
of
good
room.
idea. I was gonna say nobody wants wires going all over there.
Right.
Right.
Yeah.
Okay.
'cause-
I got you.
Actually, you have a transhumeral kit there. Have you tried measuring his tricep as well as his bicep? Because with us, with working joints, we can't flex just one. Because I mean, you need to flex the other for opposition. But I wonder if a kid that hasn't got a joint down there can flex just one or the other. Because I'm pretty sure that transradials can do that with their 2 wrist flexors.
So can you get 2 inputs, like one on top of your forearm and one below your forearm, or one in your bicep and one in your tricep? Would that be possible?
Yeah, 2 is entirely reasonable.
Hi, Charles.
2 is
hi,
possible. Okay. Okay.
Albert,
So have you tried that, Albert?
I think the question was, since he's not got a joint at his elbow, is he able to flex the 2 muscles in the forearm independently of each other?
2 muscles in the upper arm.
The bicep.
Sorry, upper
and
arm.
bicep.
Yeah.
Which 2? The like here and then here.
Ooh, you're having connection trouble.
Right.
The bicep and the tricep, yeah.
We haven't tested it yet. He barely has any muscle on that arm.
This guy. Yeah, that would happen, huh?
He's 6 years old and he's never used that arm. So we're looking at getting him like ankle weights.
Yeah, of course.
So maybe we were really surprised we were even able to make it work on his bicep with how little muscle there is. It's like 1/5 the voltage that my arm would produce.
Yeah. So that's interesting. And you didn't try the lats, did you? So these guys here?
No,
Because they're close to the arm and seem like they'd be big enough to be easy to hit.
we did the shoulder and then up the neck was the best.
Yeah, that makes sense.
We were actually really surprised by how much voltage this area right here actually generates.
Yeah, well, those muscles are huge. It's the traps back there.
Even in the arm muscles, we found that like this kind of motion actually produces more voltage than like this kind of a motion, at least for him. I'm not sure what causes that, but it's actually really easy to trigger just by like pulling on your wrists.
Yeah. So straightening your arm. Or straightening your elbow. Yeah. That's interesting. I hadn't played with that with my sketchy little Maya setup. And then what electrodes are you using? Disposable ones like everyone else in the DIY, or?
Yeah, we're getting ready to build our own sleeve for him to put on his bicep. But for right now, it's just the same ones.
Have you seen the 3-bar ones? They're just 3 strips of metal that they press against the skin, and I guess you're supposed to put some like conductive gel on them, and they seem to work pretty well. I saw a guy with a B-Bionic $80,000 hand that was just glorious, and it was using those. Am I having connection troubles?
No, everybody got kind of quiet for a second. I hear you fine. So, do you have a link to the 3 bars thing you're talking about?
I can look for it.
The other thing I've seen people doing, at least according to SparkFun, is like a sleeve that they're stitching conductive wires into the parts of the arm where they are getting the conductivity, and depending on that.
I cannot imagine that works well.
Yeah, I have difficulty imagining that it would work well either, but it would be easy to make sure that you're always positioning the electrodes in the right places. I think they might have been using like a button under it too, but I don't think that they're using the same kind of. Okay, Charles, I'll see you. We'll chat with you later. Okay, cool.
The bottom ones are the ones I saw. I don't know if that's just 2 sides of the same device. It probably is. Yeah, and I'm not sure that you would be able to. I'm not sure you would be able to. Wow, sorry, I just looked at the IRC channel for half a second and lost my train of thought entirely. Oh, yeah, with fabric electrodes, the placement of the electrodes is really important. I'm not sure that just having it on a sleeve would be accurate enough. But I don't know.
Okay.
So, sounds like Charles wants us to decide who's getting the Discovery unit that they're giving us. Yeah.
Yeah, they've been.
Interesting decision to make with all 4 people here.
I've been talking about it offline with a few people. Actually, people have asked that I send it their way. My short list at the moment are you, Mark, Laird, and Jeremy, or the guys at RIT.
Yeah.
Mark,
I'm not entirely confident that my my college printer will be easy to mount stuff like that too. I might get myself a little Delta that's got a tiny, very specific end effector. So I probably shouldn't take it. And
I figured.
And I can probably hack up what they're selling anyways.
Right. I was figuring that you were, because you're just starting school too, you might have a lot on your plate anyway.
Yeah, to a good extent.
I was thinking Mark Petrykowski. I've invited him. He hasn't shown up yet, but I was thinking that he would be a good choice, or John and Joshua at RIT.
Yeah. I'd say Dale, but I have no idea what he's doing after Amory's over. I think you're sticking around for a while, right? But, no.
For a little while at least. Don't know how long.
He's been doing all of the flexible stuff here.
Yeah, I kind of figured that I was a bad choice for it.
Have you got your printer working?
Given that I do, in fact, but that was the weekend. I got it working this weekend, so there are probably still some kinks I need to work out of it.
Usually are.
Yeah.
Yeah.
So, Albert, did you get a look at that that link that Nick just posted? Albert?
I'm looking at it right now.
Oh, okay.
It's trying to load.
Oh, understood.
So, I'm pretty sure that I think one of the nice tricks with that kind of electrode is that it doesn't need a ground placed on the skeleton. It just since it has 3 channels all on the muscle, it can figure out the common mode between all 3 and get rid of it that way. That makes sense.
Wow.
Yeah. But there is some black magic involved in those electrodes. I read a academic paper about it, and you need to figure out the wavelength or the frequency, whatever, of the muscle, and then space the electrode appropriately so that you're not getting like destructive interference between the 2 or some weird thing. Like, it's really complicated.
Okay.
So we might just call up Fabrice, who's got that arm, ask him to measure it and copy their design. That might be a good route, but other than that, I would not attempt those. I was just wondering if you had found a cheap.
Get rid of ours.
Hmm?
We want to get rid of ours and make our own.
Yeah, the nice advantage of that thing is that it's permanent. You don't need to replace it really. But you do need to put this conductive gel on it, which is annoying. And they're like $300 because they can charge insurance. Why not?
This is the link to that fabric electrodes.
Yeah.
The other thing I've been playing with that is related, but I don't know how much. I don't know what they're actually. There's no electronic connection, except on the clip on the ear. Are these Nico Mimi ears?
I've not heard of that.
Go ahead and click the link, the second link I just posted. They're cat ears that respond to varying frequencies of EEG signal, and I think it's just frequency. Like alpha versus beta versus whatever, and they have different. They show mood is how they describe them, but they're robotic cat ears that you use.
That sounds an awful lot like the, I don't remember what it was called. There was a Sega or one of the old game consoles, from when you were a kid,
right,
had this brain sensing thing that was really pretty much just an EMG sensing your forehead muscles.
Right.
So the most effective way to play the game was to just go like that, or just
squint your eyes,
scrunch your eyebrows. So yeah, I would be hesitant to believe any super low cost, low number of electrode EEG thing.
Let me go grab mine. I'll bring it up here. Hold on a second. I'll be back.
Okay. What on earth were we talking about before cat ears?
So, who made the flex hand?
That is Steve Wood. I think he sells Filaflex, but yeah, that's a nice trick. And then we also built some here at Amory with silicone.
I thought the Philflex company just donated a bunch to him to work on stuff.
Is that? Oh, I have no idea. I just assumed.
Okay, because I'm trying to figure out who to give credit to.
Yeah, probably Steve Wood. Which flex hand? There's been a few. I think it's probably him though.
Flex hand too.
It's definitely Steve Wood.
Yeah.
Yeah, it's Steve Wood.
Mm-hmm. Yeah, so try moving your eyebrows.
Give me a second to turn it on. Getting my earplugs back in. Let's see.
That is ridiculous.
They are. They're pretty silly. Mostly they indicate that I'm embarrassed.
Are you doing this on purpose, or?
No, there's not a whole lot. Yeah. I can't really control them. I haven't figured out. Haven't figured out what kind of thinking to do to make them behave in different ways. But yeah, they're ridiculous. They have a clip that goes on the left ear, and the piece that goes over the forehead. A lot more fun, I think, if you're a 19-year-old girl than if you're a 40-year-old man. But I had to try them out just to see what they do.
Okay.
My sister loved them.
That is so strange. I was expecting them to like flap forwards, not rotate. That's so bizarre. Ears don't do that.
Yeah, right. Cat ears kind of do, but not a lot.
Not nearly
dog
that
ears
much.
do.
It turns like 90 degrees at the beginning.
Yeah, and when one is turned 90 degrees and the other one is pointing straight up, they say that it's still reading it. It hasn't been reading your EEG long enough to have a pattern yet. So the initial look was that, yeah. And it comes with a little card that explains what the different movements mean about how you're thinking. They also make a version of this that is a tail that wags. Based on, yeah. Probably fun for going to conventions, but hard to take anyone serious wearing them, I think.
Yeah. So that's probably not useful.
Yeah, but the science behind it is what we need to explain.
Yeah.
And the ears are replaceable. They're basically just a very small servo rotating a block of plastic that fits the ear.
Mm-hmm. So you're releasing.
But yeah, it's got a. So it does have a metallic contact at the forehead, and then the rest is just ear clip.
You're releasing your design on Friday, right?
Yeah.
Yeah, I think so.
Okay.
We wanted to wait until we do the handover with the family before we started posting it.
Yeah, that makes sense.
Right.
Makes it cuter. Yeah, you should be sure to just like send a link to Hackaday and make media and all that. They'll probably post about it.
Yeah, my university is currently contacting John to try to get some quotes from him, so they're trying to do it that way for the press release. So
Yeah, that'll
we're trying to
awesome.
give e-NABLE the credit.
Yeah, that's great. I confused you with Albert Chi when you were in the Hangout the other night. The like leading neuroscience guy at Johns Hopkins. I was really confused.
I'm a little young.
Yeah, you are.
Yeah.
Anyways,
Got a couple more years before I get my PhD.
yeah. And your like own research division or whatever that guy has.
You've also a head full of hair, whereas she had a shaved head.
So I kind of already talked about the whole casting a whole finger in silicone thing last night. Or I guess that was after we were on air. I should probably have that with me, but it's in the lab and taken apart right now. So,
Hold on one second, I'll be back.
okay.
You guys go ahead and keep talking without me.
Yeah, so essentially, yeah, that's not
One thing.
Essentially, you know what? I'll just go get it. It's not that taken apart. Back in like 30.
One thing we're trying to do is design a single piece finger that you can print multiple types of material for, and like at a really advanced 3D printer. It wouldn't be available for anyone else, but
It's electioneering time. So we're getting people campaigning, knocking on doors. I also live in Mormon country, so there's a lot of knocking on doors seems standard operating procedure.
Mm-hmm.
So, yeah, I didn't really have a lot for the agenda today. Is Nick off grabbing something, or is he?
Yeah, he's getting
fingers,
his silicone-coated finger design.
Cool. I do want to check those out.
Hey everyone. Not interrupting anything?
Hello.
Cool.
Nope.
So I hope this is, yeah, it's printed right. So I counted up this little dude, which is just, yeah, I can pull it apart. It's just a little arc-shaped concavity on the distal side, and then a cylinder with rounded edges on the proximal side. And then there's a hole through each, and I use a loop of string to hold them together. And that's pretty much exactly imitating how the interphalangeal, this joint here, of real fingers is made. And my hope was that I could make this whole assembly and then cast all of it in silicone and just have a flesh finger that worked like a real one, and he just pulled the string on the back to flex it. And I was also hoping that this stuff would provide the return mechanism for this, because you'll notice I haven't built anything in to pop it back up when I bend it. Unfortunately, I made this whole test way too big and the silicone in the test way too thick. So it was extremely rigid, and I kind of just dissected it to see what was going on. But I think it might be interesting in a week or two when I've made something worthwhile out of it. I don't know. The end goal with it is to be able to print out and assemble a little skeletal hand and then just cast the whole thing in silicone so it has like flesh almost. And there was some trouble with getting material in the channels and that getting the string stuck, but I think if I just use a fishing line instead, that should probably go away, because the fishing line is pretty smooth.
They make really, really small fishing line too.
Yeah, that's another part of it. I was thinking I might use little dabs of clay to seal all of the channels, because I mean a little tiny bead of clay isn't going to add any friction to a fishing line, but it'll keep the silicone out so that you don't end up with a whole channel full of silicone. Right. And just not worry about ever getting the clay out. Just make it become part of the hand.
Does the silicone expand as it dries?
I don't believe so. I think it
You have
stays
to-
the same size.
Do you have to degas it at all?
We should if we really cared, but
But it's working fine
yeah.
for us without doing that.
Yeah, I didn't bother with this. That just okay. You can't actually see the bubbles, but there's some pretty small bubbles in it. Like there aren't any big enough that it affects surface finish. It's just it makes it less translucent, transparent.
Yeah. It may affect long-term use, but it should be fine.
Yeah. Yep. So I'll retry a smaller one of those this week and see what comes of that. Because I really like the idea of a whole flesh hand. Because the silicone doesn't stick to any part of the skeleton or any part of the print or the string too badly. So if it gets just like horribly beat up after 6 months or whatever, it wouldn't be particularly difficult to tear all of the silicone right off and cast it again. Or for that matter, I'm pretty sure that you can cast additional silicone onto a piece of silicone and it doesn't, it's not like there's a seam, it just casts perfectly onto it, bonds as if it were cast as one part. So you might be able to take a damaged hand and just fill the mold with a bit more silicone, shut it back in the mold, wait 12 hours, and all of the little cracks will be fixed up. Might work, I don't know.
Keep pinging Mark to see if he can join.
Yeah, presumably it's busy. So I guess we should talk about who to give the. Oops, why did I just get a? Never mind, it's a different app. We should talk about who to give the structure 3D to. The upside of giving it to RIT is that they'll use it for transradial stuff and printing sockets and all that sort of stuff, which
Right.
Which Mark's doing less of. He's pretty focused on the Cyborg Beast.
Right.
Jeremy, I don't know how much R&D Jeremy's doing. Isn't he mostly distributing Cyborg Beasts?
At the moment, yes. At the moment, yes. But he's done a lot of testing of materials in the past. He did a lot of videos about the atomic bridge.
Yeah, that's a good point. He's probably the best choice for them because he'll write a review about it on 3D Universe.
Right.
Yeah.
Yeah, that was the other thing I was thinking about. Is he does review of materials on his website, so it would be good for them if.
So that probably makes the most sense. I'd say go with Jeremy.
Yeah, but the only person who has asked for it so far has been Mark, and so. But I need to start bouncing the idea off of. Yeah, well, I figure I'm not sure who all heard that we have one that we're going to be giving away, that they're giving away to one of us. So,
I mean,
and I'm not sure that. Yeah, and I'm not sure that anybody else is aware that I'm the one who has to or has been given the decision. So. So yeah, Mark's asked. He said that the group at Crichton has his university called. Okay. CREIGHTON.
Yeah, I don't know the pronunciation.
I've never heard anybody say it. I've seen it written. Crichton. That sounds like I would expect it to sound. But he said that he and the group that he has with him at Creighton University could find a lot of things to do with it. They've got 4 printers at their disposal, and 2 of them are dual extruder. So he almost certainly can find a machine that he can reserve for testing dual material tests on. And he's got a list of things he wants to try out. So those are things in his favor. I'd like to talk to the guys at RIT and see if they have any decisions, but is John on the road, or is he just... Because I know he was at the Fab Labs in Spain, like last week or the week before.
I believe he's back in Rochester.
Okay. Yeah, he's been notably absent. He was briefly on the call last night and then away. So I was thinking maybe he had a lot going on, but he's one I want to ask about what we should do.
Yeah.
I like the idea of giving it to Mark, but I also like the idea of giving it to RIT. And if you and Dale have things you specifically want to do with it, I like that idea too.
Let's not worry about it for now. First of all, we're on air, and second
Okay.
of all, we might as well just, ask a bunch more people. That's what we're getting at here.
Yeah, that's what I was hoping, is that there'd be enough people in this conversation that we could actually have a conversation about it.
Mm-hmm.
But I'll post something on the list and see if I can get comments. Maybe that will get some answers. I also probably shouldn't have scheduled this later in the evening like I did. Usually I do this at 5 instead of 6 or whatever it is for everybody else's time zone. So I did it like an hour later than I usually do.
I don't think it's much of a
And that
problem.
might have affected the turnout.
Maybe.
So anything else anybody is doing that is interesting?
Back to cast silicone. This is pretty similar to what Nick did, but I have just the fingertips cast in the dragon skin silicone, and they're amazingly grippy. You can hold all sorts of oddly shaped things.
Oh wow!
Wow, you hadn't demonstrated stuff like that for me. That's impressive.
And it's something that could be incorporated into other designs really easily, because basically underneath the silicone piece is just a rectangle and a cylinder and sort of a hook thing to hold onto it. And it would be easy to replace the fingertip on a Cyborg Beast or Flexi Hand or any of that with that, and then you just stick the finger in a mold that would be a negative shape of the original fingertip, and then cast it right on there.
Has anybody tried the trick we were suggesting last night with the Lee Tippy finger grippies and using acetone to get it to adhere to the ABS?
Mm-mm. Or someone might have tried
Jeremy
it.
said he was going to attempt it.
Yeah.
I'm going to be getting them. So
Jeremy said he was going to attempt it, I think. Okay.
Yeah.
Was that Albert or Dale that said that?
Albert.
Okay, Albert. Yeah, those have gotten pretty good reviews from Peregrine, who, uses. He and his dad built a hand, and he's been using it out in the field doing work. So he's got a lot of useful input.
I just hope they fit.
Yeah, that's
They're
the
pretty
big
stretchy.
one, I might say. Oh, really? Well then. I didn't realize.
Yeah,
there was
the silicone is pretty stretchy.
Is it-
Yeah, they're designed to go around a wide range of finger sizes. So, and they're kind of one size fits all. I think they might have a couple of sizes, but they're not.
Yeah.
They're not sizes with measurements, and not more than like 2 or 3 sizes.
Well, sounds like a good choice. Yeah, I don't have much else to report.
Okay.
We're trying the new Kevlar string tomorrow to see how that helps with strength and then long-term operation resistance.
Yeah, braided Kevlar.
Pardon?
It's like braided Kevlar. It's like 3 little tiny strands made into one reasonably sized string.
I haven't seen it yet. It arrives tomorrow.
Okay.
But it's like 0.65 millimeter, so it's small.
Yeah, that sounds like the stuff. We, or I think Peregrine was the one that was trying that, and he said that like a tiny saw blade and cut away at his parts over time.
That is one of the downsides of Kevlar, is that it's
Yeah.
super strong. We'll see. It depends on how you tie your knot. So we're gonna try it at least. The nylon cord.
It might also. I was gonna say it might also help if you can put metal tubes down any of the tubes that it has to go down, or over any of the corners that it curves over, putting something under it to keep it from cutting into it. But
Okay.
yeah,
I've even looked at like some
Yeah,
epoxies that you can put over it, and I think that's the best way to go. The ones I got are actually coated.
yeah.
Like, I found some that are coated in Teflon, so that might be the best bet.
Okay.
That would be great. You should try those. That sounds like
They're a little bit
fantastic.
too big. They're like right at a millimeter, so I went with the other ones for now, but it's something I'm going to test in the future. I work with Kevlar in my research lab anyway, so I figured it'd be cool to try.
I think we use 1.5mm stuff for most of the designs. No, that's not right. No, maybe it is. But no, the shade cord stuff that we all use is in the Cyborg Beast instructions. It's whatever. Yeah, the mill's not out of the question for size, I don't think.
We also looked at carbon fiber wrapped in Teflon, but it also was a little bit too large for what I was hoping for. So, but they're all different things I want to try,
Yeah, certainly.
and they're pretty inexpensive.
Wait, how inexpensive? $30 a roll or something like that.
It was sold by the foot, and it was only like $1 a foot, and like that's several.
Yeah.
It was the shipping that was going to be the cost. It was like $20 for shipping, and then like $1 per foot. So
Yeah. So I mean, but if we end up using it, Jeremy would just buy like 1,000 feet and then put it in kits, so shipping wouldn't hurt him. So I have a little design for the Schreiner's kid, but it's not really interesting. It's we basically just scanned his hand, took a print of it, and then cast a silicone sleeve around that. So he'll just have like his hand, a little bit of silicone, and then the actual prosthetic around it. These kids have one finger and then the 2 and 3 metacarpal bones and nothing else on their hand. So we're trying to come up with something that like keeps that one finger and the front of the palm as part of the actual hand. But yeah, there's not a lot of exciting stuff to talk about on that front. I'll have more interesting stuff to show you guys after we try it on him next Monday, hopefully. I think I'm about done. Anyone else?
I'm running a stress test right now on one of Steve Wood's all Filaflex fingers, so we can compare that with the silicone.
That'll be good.
I'd also like to see that done with the Tallman Bridge fingers. I don't remember who posted that. Was that Jeremy that printed that?
It might have been.
But yeah, the Tallman Bridge nylon flexi fingers looks pretty interesting. Just because the filament was basically just nylon, and it was straight through the entire length of the finger, so it should be pretty strong. But I'd be interested in seeing how that handles up to the repeated flexing of your stress test. With Albert's device, they could probably do the stress test just by writing software to do it, since it's already all stepper motor controlled.
Yeah. So yeah, you can run those tests. I think we're pretty much wrapping up.
Yeah, I don't have a lot. Like I said, not a lot on the agenda. I tried to come up with things that have been showing up in topics on the conversations lately, but there really wasn't a lot. And if the people that I mentioned that had posted those things aren't here, then we'd be basically just talking about them rather than talking to them.
Okay. Want to take us off air then?
Yeah, go ahead. Or give me a second. I'll do it. We are Stopping the broadcast now.